All right, we are going to be talking about toxicology or studying toxins today. We're actually going to skip around a little bit. So what I need you to do is turn to page 3, where it has Roman numeral 3, and it says toxicology and chemical risks. That's where we're going to be starting, where it says types of chemicals, neurotoxins. Again, this is on page 3. If you do not have a notes packet, you can find them behind my desk in the brown stackable file, like stacking thing. Who knows what it's called? You can find it there. All right, so types of chemicals. Apparently my slides got out of order. So the first type of chemical here we're going to talk about is neurotoxin. Notice the word neuro, like a neurosurgeon. Neurosurgeon works on what? They work on brains, right? Or the nervous system. So neurotoxins disrupt the nervous system. Remember yesterday we talked about if you don't know a health impact, it's always a good idea that you could say, oh, it disrupts the nervous system or disrupts the reproductive system, because many chemicals do just that. So insects are really susceptible to neurotoxins and to nervous system damage. So what we actually do is we use chemicals that disrupt the nervous system in insects in order to deal with pests in our agricultural fields. Okay, so a lot of our pesticides. Okay, so if you look, I'll move this in a second so you can write. But this is glyphosate. Glyphosate is the active ingredient in Roundup, which is the weed killer. And you can see high concentrations, right? How many pounds per square mile are they using of this pesticide? So think about it for a minute. Pounds, 88 pounds. How much is 88 pounds? Well, that's like a small child, right? They're using that for every square mile of field. And you can see in Wisconsin here, we have pretty high use because we have a lot of agricultural fields. That's why the Midwest, right? We grow a lot of crops here in the Midwest. And so how this pesticide works, it disrupts the nervous system and basically ends up killing the insects. What are some other neurotoxins? Lead. Okay, so we talked about lead being in gasoline or in pipes. Mercury, that's what was in the thermometers back in the day. This is from burning fossil fuels, also from fish. Arsenic, that's the one we talked about in groundwater, and it can be hazardous, and it can actually kill you. And then pesticides. You can also see from this list here, you can see toluene, ethanol, right? You guys know what happens when you drink alcohol. It messes with your perception, right? Your balance, your coordination. You start slurring your speech. That's all because it's affecting your nervous system, okay? Lead, polybrominated ethers. These are the fire retardants that they talked about putting in pillows. And then DDT, remember that was with the bald eagles, right? They sprayed this on the farmer's field and it got into the fish. So all these are neurotoxins. Carcinogens. Notice this sounds very similar to the word cancer. A carcinogen is a chemical that causes cancer. There are lots and lots of carcinogens around us. Examples are asbestos. Does anyone remember where we find asbestos? Asbestos is in old walls or in old foundations. They used to use asbestos, and it has those little fibers, and they get in your respiratory tract and can cause lung cancer. PCBs, these are in plastics. Formaldehyde, that's the preservative that they used to use to preserve, like, the frogs that you dissected. They would use it as a preservative, okay? Well, then they realized it caused cancer, so it's probably not a good idea to have small children cutting up rats and frogs that have been soaked in formaldehyde. And then, as we know, tobacco causes cancer and a lot of the chemicals that are in cigarettes. So do these cause cancer immediately? No. Usually it takes 10 to 40 years before they're actually going to cause cancer. Okay? So what other things cause cancer? Obviously pesticides, right? Sunlight, vehicle emissions. They talk about, preservatives, tobacco, vinyl and paint, asbestos, okay? And then certain viruses, right, like the herpes virus or HPV, can cause cancers like cervical cancer or other types of cancer. So lots and lots of carcinogens. All right, then we have teratogens. These interfere with development of embryos or fetuses, basically babies, when they're still in the womb. Okay, so one drug was prescribed or used to be prescribed to make people feel better and so that they didn't have morning sickness, but it actually led to tons and tons of birth defects. Other things, think about what you should and shouldn't consume when you're pregnant. Alcohol, right? Because we know that alcohol leads to birth defects and interferes with their development. Radiation, X-rays, right? When you go to the dentist or the doctor, they always ask, is there a chance you're pregnant? Because radiation is going to hurt the embryo or fetus. Arsenic, lead, DDT, pesticides, all of those things, okay? There's some concern about using like antibiotics while pregnant. There aren't a ton of studies out there that show a lot, but these are all things we need to be aware of. All right, allergens, things that cause allergies, right? They cause allergic reactions. Well, what is an allergic reaction? Well, it's basically when your immune system responds by attacking something that's normal. So normally your immune system would attack like bacteria or viruses, but in this case, something normal like a food or a pollen triggers your immune system and says, oh my gosh, immune system, we have to react and fight it off, and you get, watery eyes and runny nose. So you know what common allergens are, things that cause allergies. Mold, pollen, peanuts, milk, shellfish, okay? So these are all different allergens. All right, the next set, endocrine. Your endocrine system is your hormone system. So endocrine disruptors are disrupting your hormones, okay? So what do your hormones actually do? Well, your hormones are going to tell your body what to do. They send signals, okay? So if your hormones don't function properly, the signals aren't going to be sent properly, and your body is not going to have the correct responses to different signals, okay? So a lot of times we think hormones and reproduction. Well, that is true, but it can also cause other things as well, because you need hormones. You release hormones during times of stress. You release hormones, that cause your body to grow. Okay, so there's different hormones for different time periods. So where do these hormones come from? Animal feed. Why would they want to give an animal hormones? Well, they give them growth hormone. Those animals are going to grow a lot faster. Okay, I've shown you pictures before of chickens, right? Chickens back in the day used to be super tiny. Now they're super, super big. Why? Because they feed them all of these hormones to make them grow really fast so they can get more meat. Okay, we talked about industrial agriculture is worried about profit. Birth control pills, those disrupt your hormones, but they do it on purpose. That's why we take them, okay? We take them because it stops your body from releasing an egg so that you can't get pregnant. Some pesticides, actually most pesticides, but the key here is they have to be in large enough quantities. So that's why people who work with pesticides in, say, a pesticide factory or they spray pesticides, a lot of times have a lot more health issues than somebody who just, is a regular old person and doesn't have a lot of contact with pesticides. And then BPA. Where have you seen BPA? Where do you see BPA free? Water bottles, right? So they found that BPA in high quantities can disrupt your hormones. And BPA is what gets leached from the plastic in bottles over time. Okay, and that's why your water bottles say BPA free. So here's the problem. When we send our old water to a wastewater treatment plant, they don't clean out a lot of these hormones, okay? And these can cause problems with reproduction. So a lot of people suspect that there are a lot of hormones in our actual water, and they're causing quite a bit of issues with reproduction. So this slide just shows BPA, which its full name is bisphenol A, and that's the one that I said was found in plastics. It's found in water bottles. So if you notice, bisphenol A looks very, very similar to estrogen. Okay, so one of these is bisphenol A, and one of these is estrogen, and you can see that the molecular structures are very, very similar. So it's found in plastic storage items, baby items, water bottles, canned foods, and it's linked to breast cancer, infertility, neurological disorders. So they say opt for plastic-free items, try glass and metal water bottles, or just look for something that says made without BPA. All right, so how do scientists know all of this? Well, they look at dose response studies, okay? In dose response studies, what they do is they give individuals different amounts of a chemical and then look at what happens, right? So they give them different doses, like a dose is the amount, and then they look at the response, okay? So we're going to talk about acute versus chronic, and you need to know the words because they're going to apply to a couple different terms here. So an acute study would be one that lasts for a short amount of time. So you'd see somebody come in for a couple days, they'd do a study, and then a chronic study would last a longer period of time. So this would last years. Sometimes they follow them all the way from when they're a child to they're an adult. And what they're looking at here, what are the long-term effects of, you know, exposure or of their genetics or whatever. And so they're going to look at that through a long period of time. So just in terms of acute versus chronic, we have what's called acute diseases. These come on rapidly and have a short course of time. Now, you don't have this in your packet, so don't worry too much about this. I just need you to know the difference between acute and chronic. Acute means short-term, chronic means long-term. So if we have acute disease, that means it's coming on rapidly, has a short course. It's going to be over with, right? So like a cold. A chronic disease, like type 1 diabetes, you're going to have your whole life. An acute study we just talked about, and a chronic study, an acute exposure of toxin, short-term exposure. Somebody poisons your drink, okay? Or you go to Mexico for a day and drink the water, okay? Or, you know, you go to somebody's house and inhale a whole bunch of mold. That would be an acute exposure. Chronic exposure would be you're exposed to it over a long period of time. So there's lead in your water. You live with somebody who is a smoker, or you are a smoker. You have mold in the walls of your house, so you're exposed to that every single day. That would be chronic exposure. So what we do is we look at dose responses, okay? So we can make a little graph here. And what they do is they said, okay, so we're going to give individuals different doses. So the doses are down here on the bottom. Okay, and we're going to measure what happens. Now, do you think they do this with humans? Nope, because guess what? People die, and that would be highly unethical. So they use laboratory organisms. A lot of times they use rats, okay? They give these rats different doses, okay, and they determine what happens. So the threshold, okay, the dose at which an effect can be detected. So if we look at this graph, okay, I want you to label the threshold on here. The threshold is where we start to see a mortality increase. So where do we see that on this graph? Right here. So I want you on that graph, on the next page, write down, this is the threshold. It's where we start to see an increase in mortality, meaning the body can handle this smaller amount. Once we get to this point, individuals are going to start dying, okay? So that's our threshold. Now, we have LD50. This stands for lethal dose that kills 50% of organisms. So this is super important because There are millions and millions of AP questions on this. Guarantee you there will be one on the AP exam. How do you find the LD50? Super easy. All you do is you find 50% mortality, okay? And you look at what dose caused 50% mortality, okay? So you can just draw a line straight down. So I'd recommend drawing this on your graph, okay? And you'll notice that we have, at 50%, it's 250, and this is micrograms, which looks like milligrams. So this is the LD50. So make sure you label the LD50 on your graph. And I know it says 232. We're just going to say it's 250 because that's easier. All right. Last thing here. So scientists compare the LD50s, the lethal dose of different chemicals, to determine how lethal they are. Right? So, for example, if it has a lethal dose of 1 milligram, okay, where 50% of people die if you only have 1 milligram, versus if I give you 100 milligrams, which chemical is going to be more lethal? Well, the one that only takes a small dose to get a lot of people to die, right? So we're going to look at the LD50 for different things, but like in rats. Notice we have table sugar here. It takes a lot of table sugar in order to make 50% of our rats die, okay? Sodium cyanide, that's a poison, doesn't take that much. Okay, yes, of course, they have cocaine and caffeine and DDT and a bunch of other stuff on there. But you can look at that. Lastly, the safe concentration. So how can we find what's the safe concentration? Notice they have the threshold dose here and the LD50. So it's found by taking the LD50 and dividing it by 10. Okay? So found by taking the LD50 and dividing it by 10. Typically, they say as long as you have 10% of the LD50, you're going to be safe. Okay? So in our last example, right, where we saw that the LD50 was 250, okay, which is the example that's given to you. If the LD50 of a chemical is 250, what is the dose at which the chemical is considered safe? Okay? So if we go to that question, if it's 250, all we have to do is take 250 times 10%. Remember, if it's times 10%, we just move the decimal over 1. So at what dose? 25 grams. You can have up to 25 grams and it's still going to be safe. Okay? So back on this graph here, okay, if the LD50 is 20 milligrams, what is going to be the safe concentration? 20 times 0.1 equals 2. 2, and then notice this is milligrams. Okay? All right. We can also have sublethal effects, and these are effects that don't kill an organism but still affect its behavior. Okay? So they'll still be alive, but they might be abnormal. If it's lethal, that means some people are going to die. Okay? If it's sublethal, then we're just going to get some weird organisms. And it might be kind of hard to see from your point of view here, but there's some that are growing weird and weird-shaped. Okay, and so you can see we get frog abnormalities given different toxins, and we'll talk more about that. All right, what I need you to do is you can put away your notes. You're going to be given a chart. You need to research the diseases on that chart, fill it in using the internet or your phone or whatever resources you have, and then turn it in to me when you are done.